Welcome to The Explainer. Today, we're diving into a moment that just quietly but completely made history. You see, for nearly 3 decades, a highly specific and notoriously difficult question in group theory just sat there, entirely untouched, literally frustrating the absolute brightest mathematical minds on the planet. But then, on August 1st, 2026, the silence broke. And the crazy thing? It wasn't broken by a human. We're going to look at how an AI finally solved this 27-year-old impossible math problem and why the specific way it did it changes absolutely everything.
$2,000. Think about that for a second. That is roughly the computing cost it took to crack not just that one historic mystery, but 10 historically impossible math problems. I mean, $2,000 is basically the price of laptop you might be using to watch this explainer right now. To put that into perspective, the barrier to entry for world-shattering mathematical discovery is suddenly just dropped to the price of everyday consumer hardware. It's wild.
So here's our roadmap for today. We'll start with the $2,000 math breakthrough, then meet the AI task force behind it. From there, we'll cover the Lean 4 difference, how that 27-year mystery was actually solved, why AI is really just the assistant here, and finally, what this means beyond pure mathematics. Let's get into it.
Section 1. The $2,000 math breakthrough and OpenAI's quiet August 1st drop.
You know, when OpenAI made this announcement back on August 1st, they completely bypassed their usual flashy product demos. No big stage, no standard benchmark scores. Instead, they just quietly dropped a dense 249-page manuscript filled with original, verified solutions. And, well, immediately the internet split into 2 very loud camps. On one side, you've got the singularity folks, right? They're claiming AI has officially crossed the bridge from a glorified writing assistant to a genuine research partner. But then, on the flip side, you've got the overhyped camp, rolling their eyes, pointing out, fairly, I might add, that tech giants had burned us with these AI solves math headlines before. And you know what? Both sides actually make a decent point. But the truth of what actually went down, it's far more fascinating.
All right, moving to Section 2, meet the AI task force and how Astra changes the game.
So this whole announcement centered around an internal, totally unreleased model codenamed Astra. Now, whether this eventually becomes GPT-6 or just something else entirely, we really don't know yet. But listen, the name isn't the breakthrough here. The architecture is. Think of it like this. Historically, large language models operate kind of like a really smart student taking a pop quiz. They read a prompt and boom, they generate an answer in one straight linear pass. Astra doesn't do that at all. Actually, scratch that. It's more like a highly specialized startup task force. It uses a team of AI agents that take this impossibly hard problem, break it down into tiny, manageable pieces, and then work on those pieces in parallel over long stretches of time. They're literally brainstorming, cross-referencing, and pooling their findings together to build a complete solution. It's a total game changer.
Which brings us to Section 3, the Lean 4 difference. Why solved by AI actually means something this time around.
Okay, so OpenAI didn't just put out some triumphant PR blog post and expect us to take their word for it. They actually published machine-checkable certificates for every single result right out in the open on GitHub. And these certificates were written in a programming language called Lean 4. Now, if you aren't familiar, Lean 4 is a formal, completely unforgiving mathematical proof assistant. It mechanically checks if every single logical step perfectly follows the one before it. There are absolutely no vibes here, no partial credit. You can't just skip a step because it looks right. A proof either compiles flawlessly or it totally, completely fails. The beauty of this is that you don't have to blindly trust a tech giant's marketing team. You can literally mechanically verify the math yourself.
And this strict verification, it is absolutely crucial because, let's be honest, OpenAI has a bit of a spotty track record with this stuff. Back in October 2025, a former VP claimed their model had solved 10 unsolved Erdos problems. It was this massive story until mathematician Thomas Bloom publicly called it out as a dramatic misrepresentation. Turns out the AI had just scraped existing solutions. Oops. But fast forward to May 2026, and we saw a genuine, though heavily human-refined, AI result. Then we hit August 2026. With Astra, we finally arrived at fully autonomous, undeniably verified proofs. OpenAI engineered this rigorous Lean 4 checking process precisely so that embarrassing October 2025 moment would never, ever happen again.
So let's look at the math itself. In Section 4, the 27-year mystery solved, demystifying Gromov's sophicity.
The absolute crown jewel of Astra's 10 victories settles a question that has literally been keeping mathematicians awake at night since 1999. It revolves around a concept by a guy named Mikhail Gromov called sophicity.
Now, to understand this without needing a PhD, let's just think of a group as a mathematical way to describe a set of symmetries. A sofa group is one where its infinite, mind-bending structure can be convincingly approximated using a very large but totally finite set of building blocks. It's kind of like a giant puzzle. For 27 long years, every single time mathematicians examined a new group, it turned out to be sophic. But the kicker? They couldn't definitively prove that all groups had to be sophic, nor could they find a single exception. It was just a massive mathematical dead end.
That is, until Astra found the dead end's hidden door. Astra actually built the counterexample. It provided an explicit, verified construction of a group that is absolutely not sophic. No way, right? This doesn't just close some obscure chapter in a textbook, it blows the doors off an entirely new research program. Human mathematicians are now actively scrambling to study Astra's weird, non-sophic group just to see what makes it tick.
And remember, that was just one of 10 breakthroughs. Astra also disproved Connors' rigidity conjecture from way back in 1980, solved 3 distinct Erdos problems, including problem 183, and provided the first real improvement to spear-packing density bounds since 1978. But here is the absolutely crucial part for theoretical computer science. Astra solved the closest vector problem. Why does that matter? Because it directly impacts lattice-based cryptography, which happens to be the very foundation of our post-quantum cybersecurity. So yeah, we aren't just talking abstract numbers here. This is math with massive real-world security implications.
Let's bring it back down to earth. In Section 5, AI is the assistant, grounding the hype. To really ground the hype, let's take a look at what actual working mathematicians are saying about all this. Thomas Bloom, the same guy who called out that 2025 mistake, is calling this big news. But I absolutely love this perspective from Fields medalist Terence Tao. He hit the nail on the head, saying modern AI models are not independent geniuses, but tireless, brilliant research assistants. I think that completely reframes what Astra is. It's an incredibly powerful tool that runs massive calculations and connects dots across vast amounts of literature, but it still heavily relies on human intuition. In fact, OpenAI specifically thanked outside mathematicians like Soren Popa and Francois Charles for reviewing the individual chapters. Astra generated the dense arguments, sure, but humans still had to verify the actual intent behind them. So, before we go declaring the end of human intellect and bowing down to our sci-fi overlords, let's quickly look at what Astra didn't do. For starters, it hasn't solved any of the $1,000,000 Millennium Prize problems. And that flashy $2,000 computing cost, well, that conveniently ignores the hefty server costs for all the problems Astra attempted and failed along the way. Furthermore, Astra is strictly internal right now. There's no API, no consumer access for us to play with. And remember that unforgiving lean for-proof assistant we talked about? It guarantees that step B logically follows step A, but it has no idea if step A is actually the question the mathematician meant to ask in the first place. At the end of the day, human oversight is still 100% required.
Finally, Section 6, Beyond Pure Mathematics, the Commercial and Scientific Future.
You see, pure mathematics is basically the ultimate testing ground. Why? Because you just cannot fake or hallucinate a geometric proof the way an AI might hallucinate a historical essay. Math is completely black and white. So if a multi-agent AI task force can take an open-ended question in a rigid black and white field and generate a mathematically verified answer, well, the downstream applications are going to be explosive. The very next logical step is pointing this exact same reasoning architecture at other hard, quantifiable fields. We're talking about discovering new pharmaceutical drugs, mapping incredibly complex protein folds in biology, engineering entirely new sustainable materials, or even cracking theoretical physics. Astra proved that a machine can take an impossible question, formulate a wholly original argument, and have it flawlessly verified by an impartial system.
Which leaves us with this final, provocative thought. We aren't looking at some sci-fi singularity here. What we are looking at is a relatively cheap, undeniably powerful tool that is currently sitting right at the very edge of human knowledge. So, I want you to ask yourself, what happens when an impartial, verified reasoning engine like this isn't just pointed at 27-year-old math equations, but is pointed directly at your industry's impossible problems? It is a fascinating, wide-open future, and I really hope this explainer helped you understand exactly how we just took a massive step toward it. Thanks so much for joining me on this deep dive. I'll catch you next time.